Hello friends, welcome to this course on relativistic quantum mechanics wherein we shall derive the Dirac's equation and his interpretations and predictions. In early 20th century, the prevailing notion of mechanical, deterministic and predictable universe underwent a seismic shift with the introduction of relativity and quantum mechanics. This challenged the established belief that time was absolute and that the precise measurement of particles' location was feasible. The transformation brought by these theories was profound and turned the things upside down. Quantum mechanics faced challenges, evolved through these challenges, and found its completion through incorporation of spatial theory into it, leading to the present subject known as relativistic quantum mechanics. This synthesis formed the foundation of standard model for particle physics, offering a comprehensive framework to explain a wide variety of phenomena in the field. The present course is a very lucrative to undergo in 4 hours to understand the weaving of quantum mechanics and relativity. This foundation paves the way for quantum electrodynamics QED, to which the well-known physicist and Nobel laureate Richard Feynman used to call jewel of physics. Quantum field theory and particle physics that almost explains everything is developed through the foundation of relativity and quantum mechanics. In particle physics, the Dirac's equation is the relativistic wave equation derived by the British physicist Paul Dirac in 1928. It was the first theory to fully integrate spatial relativity within the framework of quantum mechanics. Dirac's equation was validated by accurately explaining the fine structure of hydrogen atom, which we are going to discuss in this course. It has become the fundamental component of the development of standard model. The equation also predicted the existence of new form of matter, that is antimatter, which was experimentally confirmed few years later his theory. Additionally, it provided a theoretical basis for Pauli's phenomenological theory of spin, which involved multiple components of wave function. Actually, Dirac did not fully appreciate the importance of his result. However, the entitled explanation of spin as a consequence of union of quantum mechanics and relativity, and eventually the discovery of positron, represents one of the greatest trumps of theoretical physics. This accomplishment has been described as fully on par with the works of Newton, Maxwell, Einstein before him. The equation has been deemed by some of the physicists to be the real seed of modern physics. I am your instructor, Professor Shyamkant Anwane, associated with Shivaji Science College, Nagpur, affiliated to Nagpur University, and I am involved in this profession of teaching physics to students since past 3 decades. In this course, we shall go through 5 lectures and 4 sections as appearing on your screen. What all you will be able to develop out of this course, that include you will be mastering the fundamental equations of modern physics. You will have proficiency in using 4 vectors. You will derive and apply Klein-Gordon and Dirac's equation. You will develop competence in working with spinors. You can write wave functions that include spin of electron. You will be using quantum mechanics in the operator's form. You will be handling total angular momentum and Hamiltonian operator to develop a commutator. understanding the fine structure of hydrogen atom, and you will be understanding the Dirac's prediction of antimatter, that is showstopper. The important question is what you will be able to learn out of this course. And the answer is you will be able to learn the relativistic quantum mechanics that forms a basis for modern physics, to which Nobel laureate Richard Feynman called the jewel of physics. So thank you very much for your attention. Let us begin our course.